So this is the review for the random variable quiz, and we're going to start by looking at two situations. Mrs. Zimmerman is tracking her third period AP Stats class and is recording the number of absences. And then we have, she's recording the number of tardies for her sixth period AP Stats class. So the first question is basically we need to complete the table. And one thing we know about random variables is that the probabilities have to add up to 1. So if I'm trying to find this missing number right here, so let me go ahead and get that. So if I'm trying to find this missing number right there, I know that that number plus all the other probabilities must add up to 1. So I can basically just take 1 minus the sum of the other probabilities. And so I know that actually 0.36 goes in that cell. And for the other one, you can see again, I did the same thing, 1 minus the sum of the other probabilities, and that's the number that goes in that cell. So now we're going to the next problem, which is calculate and interpret the probability that x is greater than 2. So what that means is when is x greater than 2? And for the first example, whoops, let me go ahead and undo that. Hold on, there we go. Give me a sec. There we go. For the first one, it's not behaving for me. There we go. Greater than 2 is 3. The only one that is available that is greater than 2 is 3. And my little touch screen's being a little bit annoying. All right, so 3 is the only one that counts for this answer of 0.05. All right, and when we interpret, it's important to know that we are basically trying to say, we're not saying the probability is, we're explaining what does it mean. So what it means is over many, many classes, because what I'm recording are absences for classes, we expect about, don't tell me it will be, say you will expect about 5% of students to have more than 2 students, 5% of classes to have more than 2 students absent. Same thing on the other side. Let me go ahead and get back to here. You can see the over many, many classes. We expect about 68% to have less than 2 students tardy, because the right side is tardy. And again, look at the probability I'm calculating here. It's probability that x is less than 2. So what counts as less than 2? Both 0 and 1 are less than 2. All right, next one. So if we're looking at problem 3, what is the probability that at least 1 student will be absent? So at least 1, let me change the color so it matches. At least 1 means 1, 2, or 3. All right, at least 1 is 1, 2, or 3. So we just basically add up the 3 probabilities right here, or you can do 1 minus the 1 probability you're missing. At most 2, so if you say you can have at most 2 tardies, you can have 0 tardies, you can have 1 tardy, you can have 2 tardies, but not 3. So you add up the answers there for the 0, 1, and 2. Oh, let's see. I think I have an extra number there. Give me a second. Let me fix that. So 0.19, yeah, not the 0.20. So give me a sec. Okay, so that's fixed now. It says 0.19 plus 0.49 plus 0.12, and we should get 0.18. So that would be the probability that at most 2 students were tardy on any given day. Okay, next one. So use the formula to calculate and interpret the expected value. So there is a formula on your math chart. So let me go ahead and pull that up. I will need to, let me Alt-Tab. There we go. I have, well, where's my math chart? Here it is. No? Let me go ahead. Sorry, guys. Pausing. So here's your formula chart for AP Stats. Descriptive statistics is more at the beginning, and actually we get into some 2 variable stuff there. Here's the probability we learned in Unit B. And now we have the discrete random variable. So that is this piece right here. So you can see it says mean, and then it has expected value E of x equals the summation of each outcome times the probability of that outcome. Then it also shows you here standard deviation, and that is the difference between each value. So take the difference, the deviation, square it, and multiply it by its probability. And then because you want to get back to the right units, you take the square root. Remember that it's not written on here that variance is standard deviation squared. So when I'm working with you on this, most times you'll see me write in variance. So let's go ahead. Coming down here, you can see there's the formula, expected value. So what you have to do for a minimum amount of work for me is to basically go expected value of x. You should tell me what you're looking for. For example, let's see how we have probability of x equals 0, probability of x is greater than 2, probability that x is greater than 0. You should always start your work with telling me what you're finding. So here I need to see probability E of x equals. Now you can actually just write the first term. So for expected value, it's just the value, which in this case is the 0, all right, times its corresponding probability. So 0 times 0.36, 1 times 0.42, 2 times 0.17, 3 times 0.05. Same thing on this side. Now for minimum work, you can actually replace those with dots in the middle and use the calculator to actually do the calculation because it is a little tedious, all right? I'll get to the calculator after I do both this and variance and standard deviation. So then it says interpret. Don't forget, when I ask you to interpret, I actually mean it. If you don't interpret, you're not doing part of the problem. So again, expected is over many, many, all right? So I should see many, many. And always be about. We expect about. You could say the average is about. Don't say the average is, because then you're implying it definitely will be, and we don't know that. All right. So over many, many classes, expects about an average of 1.3, or you can just say expects to have about 1.33 students tardy. So probably wouldn't hurt to have the average. All right. So next one, looking at the variance. So I showed you that formula on the Cami, on the PDF. Where'd you go, PDF? Let me do that again. Oh, wrong one. Where's my PDF formula chart? There it is. So you again see that it's the difference between the value minus the mean, and that's how we're doing that. So let's get back to here. So I'm just doing the differences. Again, you can just show me variance of x equals, give me the first terms, skip the rest, put dot, 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 do the last term, and then give me the value. And finally, I want you to calculate and interpret standard deviation for the number of absent students for any given day. So what does interpret mean here? It actually changes up a little bit. So this one says we expect the number of whatever. So that you can start that to typically vary by whatever your standard deviation is about the mean of. Make sure you see the gaps that are filled there. Those are the contexts. All right. So we expect the number of whatever it is to typically vary by whatever our standard deviation is about the mean of whatever our mean is. Include context. All right. So let me show you a quick way on how to do these with the calculator. I think I have the TI-84 on here, but let me first show you the numworks because it's really cool. So normally on the TI-84, you have to go find the stats. You can see it's actually in the main screen here. So if you hit the home button, you can turn your calculator off and on with the power, but this is an online simulator. This is free. You can actually install this for free on your phone, and you can use it for free online. And I plan to have a couple of calculators in my classroom for those of you who really like it, so you can borrow it during class. But I'm going to ask you to actually use your phones unless you have one. Okay, so let's go to stats. And we got to put our data in. Oops, I got to go find my data. Well, I know the first values are 0, 1, 2, and 3. So we go 0, 1, 2. EXE is like an enter. And so it's okay. It kind of is. Then I go put in their frequencies. So you can see the frequency popped up automatically. I really like that. And then I go, it was 0.36, 0.42. Let me just do those first. 0.36, 0.42. And what were the other two values? 0.17 and 0.05. All right, so now I have my data entered. I can actually just scroll up, get back to that data thing. So you see how it's highlighted. Go to stats. And it actually tells me here it says one data point because it's relative frequency and it has a min. So it has a 5-number summary. Here's the cool thing it also calculates the range, the interquartile range, which your TI doesn't. And it's telling you it's got some nice descriptors that don't fit on the calculator for the TI because it's got a nice big screen. Well, I guess they both do. But anyways, I don't know why the TI doesn't have it. So you have population mean is 0.91, population standard deviation. And look at this. It even calculates your variance. I would normally have to tell my TI kiddos to go take that standard deviation and square it, but it's going to spit it out automatically for you. All right. So that's kind of a really cool thing. All right. So let me go ahead and pull up the TI because most of you will be using the TI. If I can, there you are. There's my TI. Give me a second. Here, I'll pause. Okay, so now I pulled up my TI calculator. I'm going to pull this over so that keyboard's a little bigger. So if you want to do this, you got to go hit Stat and Edit, just like we were doing before. And then you're going to put in your numbers 0, 1, 2, 3. And then you have to know to put in your frequencies. So we have 0.36, 0.42, 0.17, 0.05. All right. Then you go hit Stat, Calc, go make sure you go to the Calc, and then it's 1-var stats. So just that first one. Most of you are actually going to probably just do that. And that's not the same answer that we got on the NumWorks calculator, is it? We have 0.91 on the NumWorks calculator, and on the TI, we have 1.5. Who's right and who's wrong? Well, the TI's wrong, but it's not really the TI's wrong. It's operator error. So you got to be a little bit careful with the TI. Remember, I think they just added stats on. So we hit Calc, hit 1-var stats. There is a way to fix this. Do you see the second list? It says frequency list. So you have to remember to go add in your frequency list. Whereas what I did like about the NumWorks is that, and I don't work for them. I'm not getting any money. Ooh, there we go. What I did like about them is I saw automatically the frequency thing, and so it automatically did it. So it automatically knows to use it, whereas on this, you have to remember to put in list 2. So there's our mean. There's our standard deviation for the population. Notice you don't have variance on here. And there's your 5-number summary. So you can see why I'm kind of liking the NumWorks. So back to our quiz, though. And that's the end of the ad for NumWorks. Again, I am not paid or compensated anything. I just think it's better. All right. So, and you can see we took the standard deviation of the variance. And okay, we already interpreted that. Whoops, don't need that. And now we look at the last problem. So the last problem, what we're looking at is the expected value and standard deviation for combined measurements. So it's not just a measurement where you're doing, say, let's say I take my first period class, right? And I expect to have 0.91 kids absent. Well, if my class was twice as big, then I would expect to have twice as many kids absent, right? Because I'm just making the data point that I'm gathering bigger. Well, when we're going over 5 days, that's not what I'm doing. I'm actually getting 5 different data points, all right? So what I'll do, now, luckily, they actually both behave very similar in expected value. Expected value behaves as expected, so it's wonderful. So for a week of 5 classes, I would expect 4.55 tardies. I just did 5 times 0.91. But the standard deviation, because there are 5 measurements, I actually have to add the variances, not the standard deviations, all right? So I add the 5 variances, multiply that by 5, and then I take the square root and I get 1.903. So you can see 1.903 is not 5 times 0.85, but 3.6125 is 5 times 0.7225. The same thing over here. Here we had tardies. I added for all 5 days. Again, this is assuming we met 5 a week of classes. All right. And that multiply the variance by 5, not the standard deviation. You have to do that after you multiply the variance. Good luck on your quiz.